Today, in this video, we will learn how to measure frequency using CRO. Objective of this experiment is to measure frequency using CRO. Apparatus we are going to use in this experiment are CRO, frequency generator, and connecting wires. Now we will connect the circuit. We have this frequency generator. We can take different frequency using this. We will connect this with CRO, so on the screen we can see that wave, and for that wave we will measure the frequency. Okay. First we have to set up CRO, but for this experiment you have to be careful. It should be on AC, and before switching it on, always press this ground. Right? Now we will connect this circuit. We will use this frequency generator, but I'll explain this how to take or how to adjust frequency on this. Okay, this one is analog frequency generator. We can select any frequency using this knob. Okay, if it is on 20, so frequency is around 20. I'll tell you one more thing. Here we have this multiplier here. If multiplier is selected 10 here, and if you are selecting here 20, so frequency is not 20, but frequency is 20 multiplied by 10. Okay, if you are selecting here this 22, here one division is 2. So if it is 22, so 22 multiplied by 10, 220. But if you select multiplier 100, so 22 multiplied by 100, so your frequency is 2200 Hertz. Hertz is the unit of frequency. Here on off button is given, right? You can switch on using this. When it is on, you can see this LED will glow, right? And here these two terminals are here. We have to connect wire with this. Red is positive and black is negative. So now we will connect this frequency generator with CRO. But we have to start our experiment after setting up CRO. Okay. So we will connect positive with positive. So here I am connecting red wire with red terminal of this frequency generator, and it will be connected with positive of this CRO. Same way, negative means black is connected with black. Right? Now I am taking frequency here 200. How to take this? I am selecting 20 here, and multiplier. We will select multiplier 10. So frequency is 200. Now after setting up CRO, adjusting all these commands, we will switch on this power supply. Right? But still it is not connected with this. Why? Because ground is pressed. If it is pressed, that means it is not connected with any external source. It will not show you anything on the screen. It will show you only the line, because time base is on. Right? In this experiment, we have to keep time base on. Now release this ground, so you can see something on the screen. If you can't see proper waveform on the screen, you have to change this time base button. Right? Slowly change this time base button, so you can see a wave. Right? Now we have proper waveform, but the problem is here height of this wave. How to adjust the height? Height means along y-axis, and we know that to adjust the value of one division along y-axis, we have to change this. Okay, now it's out of scale, so we have to increase this value. Okay, now you can see proper waveform on the screen. Now we will measure x division on the screen. X division means along x-axis. Right? To measure this, we will use this X shift to adjust this wave at one particular point. Okay, now we will measure this starting from here. This is 0, 1, 2, 3, 4 and 5. Okay, here number of division is exactly 5. Sometimes you may have 4.8 or 4.6 or whatever it is. Small divisions are also there in decimal. You will have answer means X division. Right? So our first reading is here 5. Now you have to check the value of this. I'll show you now. I'll focus this on time base. Here you can see the value of this time base, that is 1 millisecond. This unit is also important, right? This value is 0.1, 0.2, 0.5. This is 1, 2, 5. Here this selected value is 1 millisecond. So we have to write this time base value. Time base is 1 millisecond. Reading from the screen is X division, that is we got 5. And from frequency generator, we have taken 200. Frequency equals 200 in this frequency generator. So this is 220 multiplied by 10. Here we got X division 5 and this is 1 millisecond. We will write this in observation table and calculate the frequency. I have written all these readings here. Frequency from the generator is 200 Hz. Reading from the screen of CRO, that is 5 division. Along x-axis we have measured. And the value of time base, it was 1 millisecond per division. Now we will calculate time period. For time period, to calculate time period, we will use this formula. X division multiplied by time base. X division is 5, time base is 1, 5 multiplied by 1, we will get 5. But the thing is, the value is in millisecond per division, so we will get time period equals 5 millisecond. Or we can write this in second, that means divide this by 1000, or we can write multiply by minus 3, 10 raised to power minus 3. So now this is in second. Now frequency F. How to calculate this? Look at this formula, F equals 1 over T. T is 5 into 10 raised to minus 3. So we will take 1 over . Okay, it will be exactly 200. So here our answer is 200 Hertz. So here I will write the unit also. So unit is Hertz. So here we are getting same answer. Exactly similar. Okay. Now we will take another reading. We will take another frequency. But whenever you are changing frequency or voltage or anything connected with this CRO, so what to do? Press this ground. Now I am taking here suppose 1/6, but also I am changing this multiplier, right? 100 I am taking. So now 1/6 multiplied by 100, so 1600 Hertz is the frequency. Now I'll release this ground. Right? Now here we cannot measure from this. If you are not getting proper waveform, what to do? Change this time base. Now the waveform is there, we can measure this. So now we will measure from this point, or if it is not exactly at one point, we can adjust. So I am taking for one wave. So this is 0, 1, 2. And this is 3. Okay. So here it's around 3. Actual value is not exact 3. It's 2.9 here. sorry, it's 3.2. So this value is 3.2. This is our X division. Now we will check the value of this. What is the value here? You can see this is 0.2. Okay, so value is 0.2 here. Okay, it's not 2, it's 0.2 millisecond. So this is our time base. So we will write this again in observation table. So here we have chosen 16, multiplier was 100, so it was 1600 from frequency generator. And the reading was 3.2 divisions. And reading from time base, it was 0.2 millisecond per division. Now time period, X division multiplied by time base, this formula. So it will be 3.2 multiplied by 0.2. So we will get 0.64 millisecond. That is 0.64 multiplied by 10 raised to minus 3. Now frequency 1 over 0.64 multiplied by 10 raised to minus 3. Or we can write 1000 divided by 0.64. We'll get value around 1562.5 Hertz. Okay, 1562.5 Hertz. The frequency from the generator was 1600 Hertz. It's almost similar, and we can repeat the experiment for different frequencies. We can compare frequency from generator and this CRO. So this is frequency measurement using CRO. Thank you.